let's do partial fractions. So basically, partial fractions is a method of dealing with fractions. And by fractions here, I mean fractions of polynomials. You can easily integrate a polynomial, but if you have to integrate a fraction where you have a polynomial in the numerator and polynomial in denominator, polynomial of that variable x, that's exactly where you have to use that method of partial fractions. Unless denominator is very, very simple. If denominator is just a number, you have power functions in it. You don't need any sophisticated method. I will deal with the simple case of quadratic polynomial in the denominator. And you should be able to do any quadratic denominator. So, any polynomial in numerator and any quadratic in the denominator. And there are several steps involved, and there are several cases to consider. So, let me set up the simple goals. So, the basic integrals that we keep in mind as goals are the two of that kind of form. If you have the fraction with simply x in denominator, you know this is natural log of x. And the other known integral is when you have 1 plus x squared in the denominator. Antiderivative of that is what? No, it's just tan inverse. Inverse trigonometric function. Not 1 over tangent, right? It's the inverse trigonometric function. Inverse tangent. So these are the basic things to remember. And we will reduce the general case to one of those cases. Or to combinations of those. Okay, now the first step is going to be long division. And this is a procedure that is very, very similar to the long division of numbers. And I assume you all know how to do long division of numbers. Do you all know?
It's been quite a while. Yeah.
All right, so instead of explaining general procedure, I will do an example, and maybe a couple of examples. Okay, so let's do. So we divide, let's say, x cubed minus 1 by x minus 1. Let me apply the process of long division. So how do you do the long division of numbers? You think about the first digit in the case of numbers. Now you think about the first power of x. Okay? Now everything here is about powers of x. What's the most important power of x here? X cubed is the most important, right? And the most important power there is x. So what would be the power of x that you can put here so that you multiply x squared, right? So let's multiply. You get x squared, x cubed minus x squared. And you put it as you do in division of numbers. And then you subtract. And x cubed cancels. And you have x squared minus 1. And then you subtract, right? So you have positive x squared. And then what do? You do the same thing, right? You find the power of x so that you multiply that and get x squared. And you focus on that x squared, not on the rest of it. So it will be plus x. You can multiply by x the expression x minus 1, I get x squared minus x. And then I subtract. X squared cancels, I get x minus 1. And then I finish, right? If I add 1, then multiplying by x minus 1, I get x minus 1. I subtract, I get 0. So what does this mean in terms of fractions? It means that x cubed minus 1 divided by x minus 1 is exactly equal to x squared plus x plus 1. That's exactly what it means. So, it means that if you see this fraction in the integrand, you just proceed with the long division, you end up with the powers, you finish integration. Right? And of course, this is the case when you are lucky and the division ends with no remainder. So let's consider remainders. Let's take x cubed, let's say, plus 2. For simplicity, divide by x minus 1 again. Or would you like more complicated numbers? That's fine. So, you need x squared to begin with, right? You have x cubed minus x squared. Subtract, x cubed cancels, x squared plus 2. You need x again, as in the previous case, to get x squared minus x. Subtract, x squared cancels, x plus 2 remains there. You need 1 to make x. You subtract, you get 3. Can you continue there? No, you cannot. So, this is the remainder. That means that the fraction x cubed plus 2 over x minus 1 is equal to what? Is equal to that plus that remainder over x minus 1. Now, what does it mean in terms of integration? If you were to integrate that, you would do the long division, you will quickly integrate that, and this integrates to natural logarithm. Right? So it's still pretty simple. Now the things get a little more complicated when you have to divide by quadratic. And in my case, you have to be able to divide by quadratic. So let's practice dividing by quadratic. Let's take the same x cubed plus 2 and divide by something like x squared minus x minus 1. So what's my first term?
X.
It's x, exactly. When I multiply, I get x cubed minus x squared minus x. When I subtract, x cubed cancels. I have x squared plus x plus 2. Now what do I do next? I add 1. If I multiply by 1, I get x squared minus x minus 1 there. I subtract, x squared cancels. I have x plus x, 2x plus 3. What do I do next? Can I multiply this by some power of x to get 2x? No way, right? So that means I stop here, and 2x plus 3 is my remainder. And it means that in terms of fractions, x cubed plus 2 over x squared minus x minus 1 is equal to x plus 1, which is easy to integrate, plus the fraction 2x plus 3 over x squared minus x minus 1. Well, the denominator remains the same, right? The numerator is changing. So instead of doing more examples, let's look at the general achievement of that long division. what is it that you can achieve by doing long division? Because by now you should be able to divide any polynomial, right? By any polynomial.
I mean, the integral.
Yes, it simplifies the integrand. And what exactly is the simplification? Because you started with a fraction of polynomials, you end up with a fraction of polynomials. Numerator becomes much simpler, and what is it exactly that we can say about that numerator? How much simpler is it? It is 1 power less than the denominator. This is exactly what you can always achieve. Right? If you divide by quadratic, you can always achieve the numerator to be of degree 1. If you divide by linear by degree 1, you can always achieve a number in numerator. If you divide by degree 3, the best you can get is a square. So I will only focus on quadratic in denominator. So in our case, long division reduces it to the case of degree 1 divided by square, by quadratic.